Hello everyone, welcome back to my channel. And in today's session, I want to demonstrate a C++ example on the concept of static variables and static data members. Uh, so let me start with it. And so as you can see, the hash include I was stream, and then I want to use the namespace. Okay, I'll go with the namespace standard so that I don't type standard scope resolution for cout every time. Then, so so what are static variables exactly? A static variable is said to have a single memory space, only one copy of memory space, and the value of the static variable um, is carried forward between previous function call and the next function call. So let's see that. So I'm going to define a function void, and the name of the function, let it be func1, and the parameter list is empty. And for the function definition, opening and closing curly brace, and within this function I will declare a variable static, and the declaration part is the same, the syntax is same for a static variable, except that we use the keyword, we prefix the keyword static for the declaration statement. So int is the data type, and the name of the variable, let me take it as var, and I will initialize it with 0. So then after that, I want to increment this variable by 1 every time the function is called, and then as well I want to print the value of this variable line by line. So I use this escape sequence, and then okay, so this is the function 1. The static variable is declared and as well initialized to 0, and it is incremented by 1 every time the function 1 is called, and then as well as printed. So within the main function, what I do is I'll remove the statement. I want to call the function 1. So how do I call? So to call it multiple times, I will use the for loop int I assigned with 0, I less than 3, I plus plus. So basically I want to call the function 1 3 times. So enter the for loop body. Within the for loop body, I want to call the function 1, opening and closing parenthesis, and then semicolon. So done. So now, as you can see, the function is called three times, and the static variable var will be initialized only once. Okay, and for the in the first function call, the value of the var will be incremented to 1 and it is printed as 1, and in the second function call, the value of the variable is incremented by 1 and the value has to be printed 2, and in the third function call, the value of the variable is incremented by 1 and the value should be printed as 3. So the initialization statement will happen be executed only in the first function call, and the initialization is done only once. So in the rest of the function calls, the value has to be carried forward from. Okay, that's the concept and that's the logic. So let's see the output. It has to be 1 2 3. Okay, so as we expected, the output is 1 2 3. So now I'll close this console window, and now for To show the difference of a normal variable, let me just remove this keyword static. Now now you can see the variable is initialized to 0 and it is incremented by 1 every time the function is called. But let's see the difference. What output do we get? I have just removed the keyword static, so you get the output as 111. Why is this? Because it is a normal variable, and this initialization statement executes every time the function is called, and henceforth, though the value is incremented by 1 in the previous function call, in the next function call it gets initialized to 0 again. So whereas in static that wasn't the case, so this makes this is the difference between a normal variable and a static variable. Static variable has only one copy and the value gets carried forward. Okay. Now let me show you how a static data member. So as you can see here, I haven't defined any class. So suppose if I define a class, let me comment out this one, and I want to define a class. Okay, where is one second? Okay, okay, so second. Okay, one second. I'll just I want to comment this whole function, so it's commented now. So I will define a class. So class keyword, and then the name of the class, let it be as sample, opening and closing curly brace ended with semicolon. That's the class definition. So within this class, under the public, so the static members are always declared under a public access specifier. So I'm using this public, and then the static variable declaration is as same as we did it previously. Static data type and then variable name, let me take it as uh, x. Okay. Okay, the declaration is done. So now then I want a member function as well. So member function, now I'll take it as function 2, and then no parameters, and then function body. So within this function I want to once again increment the value. I want to increment the value of the static variable. Okay, I'm incrementing it by 1, and as well printing the value of the variable. Okay, line by line. Okay, so now within this function, so within the main function I have to declare an object for the class sample. So the object name is 1, and then object 1, and how do I call this function func1? Using the object name and dot operator. Right, so done. And then okay, function 2, I want to call the invoke the function 2. Okay, so this is the logic is same here, but I'm just using a class definition and a class object to access the to access the member function, as well as to see the concept of static variable. So here, before calling the function, as you can see, I haven't initialized. I can't initialize it within the class. I do get a red underline here. It's only supported in the advanced versions of C++, so maybe in 14 and 17, but mine is not a C++ 14 version, so I have to initialize it outside the class. So using the data type and the name of the static variable is x. So how do we access a static variable? Using the class name and scope resolution operator, and then you can assign it with 0, any value. Okay, so done. So once again, so here the output will be the same, 1 2 3. Okay, I'll run the code. Okay, this is the concept of static data members. Okay, you can see the output as expected, 1 2 3. The value is carried forward for the next function calls. Okay, so suppose I can show you the difference here as well between a static data member and a normal data member. Suppose say I declare a normal data member by name y, and then okay, I will comment this member function func2. Okay, commented, and then okay, so the static variable is initialized to 0. That's done. And an object 1 is declared for the class sample. And I don't want this for loop anymore. And I'll comment it. Okay. And now I just want to show you the difference between the static data member and a normal data member. Suppose, see here, I want to declare an object, another object by name object 2. So now object 1, through object 1 I'll access a static variable and assign it with 20. Done. And through object 2 I will access the static variable and assign it with 30. Done. Similarly, I do it for the normal data member as well. Using the object 1 I will assign it with 300, and using the another instance object 2 I will assign the data member y with 400. Okay, so now you can see this, and after all these assignments I want to print the state values. Okay, so first statement will be value of a static variable through object 1. Okay, and the value is accessed. Okay, I want to print line by line, so okay, done. So similarly for the other values I want to copy the statement and keep it 4 times, so that 4 different values I want to show you. Okay, so static variable through object 2. Okay, and then normal variable through object 1. Okay, the variable name is y, and the last statement normal variable through object 2. Okay, and the variable name is y. So what would be the output of this program? So we get static variable through object 1 as 20, static variable through object 2 it has to be 30, and normal variable through object 1 it is 300, normal variable through object 2 it is 400. So what should be the output? 20, 30, 300, 400, right? But let me run this. We get 20, 20, 300, 400. Okay, you can see it is 20, 20, 300, 400. To avoid this Let me make it more clearer. I will use this so that it's more clear. And okay, now as you can see, the output is 30, 30, 300, 400. Okay, I'm sorry. So it is 30, 30, 300, 400. So the first two statements, static variable through object 1, it has to be 20 actually. So what happens here is, when we create an instance object 1 and assign the static variable with 20, it is done. So next, when we create the object 2 and assign it with 30, the 20, the value 20 is rewritten by 30 because the static variable has only one copy of memory space. So that's what is the difference between the static variable and a normal variable here. Whereas in normal variable there is no overwriting of the previous value. When you access it through the object 1, it shows 300. When you access it through the object 2, it shows you 400. So that is a normal variable. It can have multiple copies of memory space for the respective objects, for the respective instances of the class. But in case of static variable, it's not the case. Suppose if I take this printing statement and keep it before assigning value 30 through object 2, then you can see it still contains the object, it still contains the value 20. You can see the output here. The first statement, that's the static variable. It contains the it contains the value 20. And then what we did is we created a new instance object 2, and we tried to assign with 30. So then the overwriting takes place. So though we are accessing the variable, though we are accessing the static member with object 1, it contains 30 because the value is overwritten. So irrespective of the objects, or irrespective of number of instances of a particular class, the static variable always contains only one copy of the memory space. So this is the concept of static variable and static data members in C++. Thank you very much.